So the purpose of today's lesson is, again, we are hitting the standard where we interpret the parameters of a linear function. So today we're going to be looking at scatter plots in section 4.4 of Big Ideas. You'll be doing page 199, 1 through 14, all. That's all. I think I'm breaking it up into two parts. So let's start with this, and I'm going to just quickly go back through. How do we write the equation of a line? These two together. How do we write the equation of a line? We have to write the equation of a line in slope-intercept form. What do I need? We need two things. We need a slope and a y-intercept. Do we know what, in number one, what the m or the b are? Raising a quiet hand. What is my m? What is my b? Do we know either of those?
Could b be 9?
B is, well, let's look at this. If this is increasing by how many?
2.
What might you think that is?
9.
2, 4, 6, 8, 9. Sophia, and what would it be? 10. Okay, so not my slope, but my b, right? Now the slope, how do I go about finding my slope? Yes, Max. We use a slope formula. M equals y2 minus y1 over x2 minus x1. Let's call this point 2 and this point 1. So here I'm subtracting my y's. 1 minus 4 over 3 minus 2. With me? Okay. Subtracting this and then this. And so we simplify, and what do we get?
-3 over 1.
Okay, and so my m equals -3, my b equals 10. What is the equation? And y equals mx plus b forms, linear slope-intercept form.
Y equals -3 times x plus 10.
We can just say -3x. Okay, next. All right, horizontal line. That should be easy enough. Usually when I have horizontal or vertical lines, I make tables and I list some of the points. 0, -3. 2, -3. I'll even take this one. -1, -3. Can anybody tell me what equation that would be? What equation would that be? Elise?
It would be y equals 0?
Nope.
No, I forgot.
Well, something's consistent. What is it?
-3.
So, what would it be?
Y equals -3.
Y equals what's consistent, right.
-3x plus
And that is because that's in the y column and it's always the same, then that means we write y equals. If it were in the x column, we'd write x equals. Yes?
Do we need the table for that one, or can we down the same?
You could have found, and what you would have done is when you take your 2 points, you would have found that your slope is 0. And then you have to just look at it. It's crossing at -3, right? You would have found that m equals 0 once you do y2 minus y1, and your b is -3. So y equals 0x minus 3, y equals -3. Does that make sense? Yes? Okay. All right, you try the next two, and be careful. Number 4 is tricky. So pause the recording, you do the next two. Okay, we need our two things, our m and our, we need our m and our b. Okay. Do we have either of those right away without doing any math?
Yeah.
What is given? B, the y-intercept, what is it? 5. Okay, now I have to find my slope. Right here. It's crossing at the 5. Okay, they told us 0, 5. So when x is 0, that's your y-intercept. And then if I'm going to find my slope, m equals y2 minus y1 over x2 minus x1. And so what would my m be? What am I doing? What am I substituting in, guys?
5 minus negative 3.
5 minus negative 3 over?
0 minus negative 3.
I want you to notice this one point, they're on top of each other. Do you see that? That's how it should look. And then we get 8 over 3. So what is the equation?
Y equals 8 over 3x
Plus 5. Okay, questions? Okay, this one was more tricky. Because this, to me, does not look like it's intersecting at 4. And so I'm going to check it another way. I've got 2 points. What can I find with that? Slope. So I'm going to go m equals y2 minus y1 over x2 minus x1. And it looks like it's more so crossing right here. What do you think? Huh? He says no. If I enlarge it right here, it looks to me like it's okay. So anyways, I'm going to I'll call this point 2 and this point 1. So I'm doing 7 minus 1 over 2 minus 1. And what do we get? 6 over 1. So my m is 6. Okay? Now, another way to write the equation, remember we learned point slope? I'm going to use 1, 1. Point slope is y minus y1 equals m times x minus x1. Y minus 1 equals 6 times x minus 1. Y minus 1 equals 6x minus 6. Add 1, add 1. What do I get? Y equals 6x minus 5. Did you guys get that?
Yeah.
So why did you say, Jamie, you were like, no, that's not it.
Because it's crossing at the negative 5, not the negative 6, and that point is negative 6.
Oh, you're right. It would be here, you're right. I'm even wrong. It's probably here. Right? You were right, and I was like, what, was he really telling me it's crossing at 4? So, I used the point slope. Do you guys remember that? Yes or no?
Yeah.
Okay, what time do we go till? 42?
40.
42.
Just 40. 940.
Well, it's 10:42.
No, it's 9:40.
It's 10:42 for third period. All right. So I'm going to skip on these. Okay, here we go. All right. So what are we doing now? The graph below represents volume of water in a tank over time. Find the equation that describes y in terms of x, that describes water level in terms of the hours. So what do we need? We need an M and B. Okay? So what is do we have any of those?
We have a B.
We have a B. The B is what? 60. And what is my M? How do I find my M? Multiple ways. What'd you say? She wants to rise over run. So what is this? No. Close, but no cigar.
Negative 20.
Okay, first of all, one jump from here to here is more than 1. What does it stand for? 10. So it's 30 over 2. 30 over negative 2. Good. And so that simplifies to what? Negative 15, and my b equals 60. So y equals negative 15x plus 60. Is that making sense?
Is this going to be on the quiz?
I'm not liking that question, okay? All right, so here we go. Now, we could have found the slope using the slope formula, but it doesn't necessarily, we don't have to. This graph is pretty clear. So everybody's clear on this?
Well, I'm not done writing.
Okay, well,
Just trying.
I'm going to skip this. This is just another example. All right, so we're starting to find our line of best fit. I'm going to remind you, we kind of went through this before, so I'm going to go through it quickly. Remember we had whatever is the depender goes in the y. So what this is saying is lifespan depends on brain weight. And we take each of these points and we plot them. Remember we did that? Yeah. And then we draw a line that will fit through it like they are little magnets and our line is metal. Okay? What can we say about it? It's increasing. Is it a positive or negative correlation? Positive, as one is increasing, the other is increasing. Means they probably have a relationship. So creating the line of best fit is really trying to draw the equation. It's not an exact equation, it's an estimation, right? We draw our line through where we can attract the most of these points, okay? And then we pick 2 points, just like we've been doing, right? They can be points on the line or near the line. Doesn't have to be. It could be like this point right here and this point right here or this point right here, actually on the line. And we take any 2 points and we find the slope. You guys with me? Okay. So I would do 50 minus 10 and 450 minus 50. And we get m is about equal to 0.1. Now, as soon as I put real data in, I switch to the about equal to. Does that make sense? And now we can use either point and do point slope or y equals mx plus b and solve for b. And we get our b, and we are able to write the equation of the line. Tonight, we're not really going to be focusing on this. We're more so going to be focusing on the other questions. Now, if I were to put the data in from the calculator, it's pretty close to what we just estimated. So look, we're, 1/100th off here, and we're 4/10 off here for our y-intercept. So it's a good enough equation to estimate for future predictions. All right, now we were talking about scatter plots below. Does this show a linear trend?
No.
No. What about this? What about this one?
No.
No. What about this one?
Yes.
Is it positive or negative correlation? Negative correlation. Starts high, ends low. D.
No.
No linear trend. E.
Yes.
Yes. Positive or negative? Okay. Starts low, ends high. And then F, linear trend?
Yes.
Yeah, but any correlation?
No.
Neither. Constant.
Vertical.
All right, so we talked about finding the line of best fit. We're going to ignore our outliers. It doesn't have to go through any of the points, just equal number of points above it, below it, okay? All right. Choose 2 points. Just a reminder, we're choosing 2 points. We don't want them too close together because look what's going to happen to my line. Are your eyes up here? Look what happens if I choose them too close together. So we want them pretty far apart. The further apart they are, the more accurate it will be. Okay? All right, we're going to skip this, and we're going to finish this up tomorrow. Okay? And I want to get to the other information. Oh my goodness, let's get to the book stuff. Okay, here we go. All right, so in your book tonight, we're going to be looking at some scatter plots. Now, what I want to show you is, let's look at this graph here. Look at this little squiggly line. That's called a break. That means, see how notice it starts at 240, but then it doesn't increase by 240s. That shows you that a whole corner of the graph is missing, that we are skipping a chunk of data from 0 to 240. And that is because there's no data between 0 and 240. Do you understand? So we use this little, it goes like this. You kind of do this at the bottom of your graph. Does that make sense? I think we go down. I guess it would be like that.
Can you just jag it?
Yeah, you can just make it jagged. But it's jagged on both ways, so it's kind of hard to see how to make just one. All right, so the first one, it says this is shows the amount of X in grams of sugar and the number of Y calories in 10 smoothies. So how many calories are in a smoothie that contains 56 grams of sugar?
270.
How'd you get that?
Because I looked at the graph and I saw.
And you found what first?
I found the sugar and then I found
Sugar what?
the grams of sugar, which is 56.
56, and then you followed it up, and we got to here. Okay, so 270 is the calories. Now, they're going to give you an output. How many grams of sugar are in the smoothie that contains 320 calories? So I'm going all the way over to 320, and I'm following it over, and we say it's 70 grams of sugar. Making sense? Okay, C. What tends to happen to the number of calories as the number of grams of sugar increases? As sugar increases, calorie increases. What kind of correlation is that? When one increases, so does the other. Is it positive or negative? It's a positive correlation. So as one quantity increases, so does the other, then it's a positive correlation. Okay? Okay, how many calories are in a smoothie that contains 51 grams? Why don't you guys each do this on your paper right now? Pause it. Give me a thumbs up when you're done. Okay, someone I haven't heard from. Nicole, how many calories are in smoothie that contains 51 grams of sugar?
260.
Yep, 260. Excellent. Oops, 260. Okay, next. How many grams of sugar in a smoothie that contains 250? Julia.
52.
Yep, 52. 52 grams. Okay, questions. So everybody's understanding that for tonight's homework. Tell whether the data shows a positive, negative, or no correlation. Age and vehicles owned. Is there a correlation? No, you could be old and not own a car. You could be young and not own a car. Okay, what about temperature and coat sales? As temperature goes down, what happens to the coat sales? So when they're opposite, what do we call that? Negative correlation. Good. All right. So tonight what they're going to have you do is plot the data, and you're going to look at it and say, is this a positive, negative, or no correlation? I'm personally, what are you thinking is going to happen? As temperature increases, do people go out?
No correlation.
I think so.
Wait, yeah.
If it's 0 degrees, do people go out? No. If it's 120 degrees, do people go out? No. But in this age, if it's nice out, people are out. People attend things. I think there would be a correlation. That's what I would think. But you'd have to go into it. So we're going to stop there. And actually, in writing our equation that models that, we're going to wait till Wednesday, tomorrow. Okay? So, does everybody remember? I need everybody bringing their student journal. The purple student journal. Okay? It should be living in your locker. So when I say I need you to go get it, and that is the recording for today.